Children, in this video we are going to discuss matrices. Is the new topic for you. So matrices means is the arrangement of elements in row wise and column wise or in a rectangular form. For example, 2, 3, minus 1, 3, 1, 0. Here we arrange the numbers in a rectangular form. So the horizontal arrangements are known as rows. The horizontal arrangements are known as rows. Like that, the vertical arrangements are known as columns. So that is, these are the columns. Okay, children. So next is you must know what is order of a matrix. Order of a matrix. That is number of rows. Number of rows by number of columns. Here in this example we have only 2 rows. Therefore the order is 2 by 3. That is the first one always which indicates the row. The second one which indicates the column. So also we used to denote the matrices by the capital letters. Okay, children. So this also you must know. After that, the general matrix also you have to remember. That is Aij is equal to Aij is an element normally. While using the bracket, it's a matrix. Now Aij is a matrix. I'm going to write the matrix. Of order 3 by 3 we can write. That is A11, A12, A13, A21, A22, A23, A31, A32, A33. This is the standard notation we are using here. See, A11 means first row, first element. First row, first element. The same thing if it is A12, which is first row, second column element. Column element. Okay, children. Otherwise, we can say first row, second element. A13 means first row, third element. A13, first row, third element. So, like this also we can write. Okay, children. So, these are the basic things you have to remember. Now, we can see the definition of the matrix. See here. A matrix is a rectangular array of elements. The horizontal arrangements are called rows and the vertical arrangements are called columns. Already I explained what is order. If a matrix A has m number of rows and n number of columns, then the order of the matrix A is number of rows by number of columns. While reading that, we have to read it as m by n or m cross n. Okay, children? Normally we used to say this as m by n. Okay? It's not normal product. It's the order of the matrix. Now we can discuss the type of the matrices. See here. In order of the matrix, just I'll give one or two examples. After that, we can go for, see here. Suppose I am taking a matrix A. A is 1, 2, 3. Here only one row is there, Therefore, it's of the order 1 by 3. The same thing B. B is equal to 1, 2, 3. So here 3 rows and 1 column. C matrix 1, 0, 0, 1. This is of order 2 by 2. These are some examples for order of the matrix. Okay, children. Here it's very clear that the first one, which has only one row, this is known as row matrix. Row matrix. Second one, it has only one column. This is known as column matrix. Now here, number of rows is equal to number of columns. This we can say as a square matrix. Okay, children. If the number of rows is equal to number of columns, which is known as square matrix. Square matrix, then general order will be n by n. Column matrix will be n by 1. Row matrix will be 1 by n, which will be the order. Okay, children, in general. Now we can see the definition of row matrix. Row matrix. A matrix is said to be row matrix if it has only one row and any number of columns. A row matrix is also called a row vector. Next is column matrix. Column matrix. The matrix is said to be column matrix if it has only one column and any number of rows. It's called a column vector. It is also called a column vector. Okay, children. So here already I discussed the examples. Please go through that. Next is square matrix. Square matrix also we discussed. A matrix in which the number of rows is equal to the number of columns is called a square matrix. Thus, a matrix A is equal to Aj m by n will be a square matrix if m is equal to n. Next is diagonal matrix. Diagonal matrix. So before going for this definition, you must know what is leading diagonal. In a square matrix, normally we used to have two diagonals. That is, just like this, A, B, C, D, E, F, G, H, I. Okay. In this one I am marking here. This is known as the leading diagonal. The diagonal which contains A, E, I is known as leading diagonal. So now we can go through the definition of diagonal matrix. Are you clear with what is leading diagonal? It's very important for this definition. A square matrix, all of whose elements except those in the leading diagonal are 0 is called a diagonal matrix. Okay, children? So, except the leading diagonal elements, all the entries must be 0. Then it's known as diagonal matrix. The examples are given indirectly. See, in the leading diagonal, we have other than 0. So, rest of that is 0. So, leading diagonal, we can have even 0, no problem. The definition says, except the leading diagonal, all the entries must be 0. Next is scalar matrix. Scalar matrix is also a diagonal matrix, which means the diagonal elements must be equal. For example, suppose there is a matrix A, which must be a square one. It's very important. First, basically, it must be a square one. Not only that, it must be a diagonal matrix. The diagonal elements must be same. Here I am considering all the entries are same. Other than that, all 0. This is known as scalar matrix. Another one, 2 by 2 scalar matrix. A, 0, 0, B. This is diagonal matrix. If it becomes scalar matrix, A must be equal to B. Here children, A must be equal to B. So I can write it must be AA. So this is an example for scalar matrix. Next is identity matrix or unit matrix. Identity matrix or unit matrix. Identity matrix is also a scalar matrix. Okay. It must have the leading diagonals as 1. So, identity matrix is a square matrix basically. It should be a diagonal matrix. It must be a scalar matrix. If it is the scalar matrix, you know that diagonal elements must be equal. Here, which is equal to 1. Okay, children. So, the examples you can see. I2 is a second order identity matrix or unit matrix 1 0 0 1. I3 is the third order unit matrix. Only the leading diagonals we have 1, other than that is 0. So you must know the basic type of matrices. Among that, the very important things are square matrix, diagonal matrix, scalar matrix, and identity matrix. Very clear, children? So these are the things are somewhat related with the previous one. Now we can go for zero matrix. Zero matrix or null matrix. Listen, children. Zero matrix means all the entries must be 0. All the elements must be 0. So normally we used to write 0 matrix. First 0 matrix, 1 by 1 0 matrix, 2 by 2 0 matrix, 3 by 3 0 matrix, etc. The last line it's given 0 0 0 0 0 0. It's a 0 matrix of order 2 by 3. Therefore, normally for 0 matrix we used to write the order. We used to write order for 0 matrix. 0, 2 by 3 is the notation. 0 matrix of order 2 by 3. Okay, children? But identity matrix, normally we won't write that. Normally, when I2 means, which understood that it's 2 by 2 matrix. Always it must be a square one. Okay, children? So, 0 matrix can be in any order, but all the entries must be 0. Next is transpose of a matrix. Transpose of a matrix. Say, If you are interchanging rows and columns, that is known as zero transpose of the matrix. So transpose of the matrix, you just know that they are matrix which is obtained by interchanging the elements in rows and columns of the given matrix. A is called the transpose of A, which is denoted by A power minus T. Sorry, A power T. Okay, children. See here, I am considering let A is equal to 2, 3, 5 minus 1, 0, 1. Therefore, A transpose will be, we have to interchange the rows and columns. First row becomes first column. So 2, 3, 5 minus 1, 0, 1. This is the transpose. Suppose I am taking again transpose for this A transpose, which will be equal to row becomes column. First row is 2 minus 1. Second row is 3 0. It becomes the second column. Third row is 5 1. It becomes 5 1. That is the third column. You compare with A. This is equal to A. Therefore, we can conclude, therefore, A transpose, the whole transpose is equal to A always. Okay, children? Next is, this is the important note. If order of A is m by n, then the order of A transpose will be n by m. Not only that, A transpose, the whole transpose is always equal to A. Here, what is the order of A in the example? It's 2 by 3. What is the order of A transpose? This is 3 rows and 2 columns. 3 by 2. Are you clear, children? So that only they given in the note. If order of A is m by n, then the order of A transpose is n by m. Also, we note that A transpose, the whole transpose is equal to A itself. Next is triangular matrix, a square matrix in which all the entries above the leading diagonals are 0 is called lower triangular matrix. So make it very clear. A square matrix in which all the entries above the leading diagonal are 0. For example, there is a matrix I am assuming A. 1, 0, 2, 1. Now, above the leading diagonal, this is the leading diagonal. Above this, all the entries are 0. Therefore, this is known as lower triangular matrix. For upper triangular matrix, B is equal to 5, 3, minus 1. Here it must be 0. Okay, children, this is known as upper triangular matrix. Here also they given the example. The first one is upper triangular and this A is upper triangular and B is lower triangular in the example, typed example. Okay, children. Next is equal matrix. Two matrices A and B are said to be equal if and only if they have the same order. The first condition is same order and each element of matrix A is equal to the corresponding elements of matrix B. So the first condition, it must be same order. Next is corresponding elements must be equal. So that is only given Aij is equal to Bij. for all I and j. So you must know that. Here I am giving one example. If one matrix X, Y, Z, 3, alpha, beta, which is equal to 3, 4, 5, gamma, minus 1, 0. Here it's of same order. Therefore, these two are equal. Also they given. Therefore, we can equate x must be equal to 3, y must be equal to 4, z must be equal to 5. Then alpha must be equal to minus 1, beta must be equal to 0, and gamma must be equal to 3. So this is equal matrix. If two matrices are equal, the corresponding elements must be equal. Okay, children. Next is here another example I am giving. Sin square alpha plus cos square alpha. One plus tan square alpha. Cot square alpha minus cosecant square alpha. Then root 2 minus root 2. Therefore, this is equal to, so it's 1. This is secant square alpha. This is minus 1, 0. These two matrices are equal since it's of same order and the corresponding elements are same. Sin square alpha plus cos square alpha value is 1. 1 plus tan square alpha is secant square alpha. Cot square alpha minus cosecant square alpha is equal to minus 1. You know that root 2 minus root 2 is 0. So these are some important results and definitions you must know. Next is negative of the matrix. The negative of the matrix A m by n is denoted by minus A m by n. Both will be of same order, only thing you have to multiply with minus 1. Okay, children. Next is additive inverse of an element k is minus k. So that is every element of minus a is the negative of the corresponding element of a. Here I am giving if a is equal to minus 1, 3, root 2, 1 by 2, minus 1, 0, then minus a is equal to 1, minus 3, minus root 2, minus 1 by 2, 1, 0. This is the required negative of the matrix. Which then both are of the same order. Given is 2 by 3 and minus a is also 2 by 3. Make it very clear. Next, you must know the scalar multiplication of a matrix. For example, suppose I am taking if a is equal to 2, 5, minus 1, 1, then find phi a matrix. So it's very simple. Phi a matrix is equal to phi into a matrix, that is 2, 5, minus 1, 1, which is equal to 10, 25, minus 5, 5. These are all the basic definitions you must know to solve the problems. In the next video, we'll discuss the problems based on these definitions.